Hi everyone. So in this video, we're going to learn about classes. We'll talk a little bit about what a class is and see how it allows us to bundle together data and functions in one single place to help us keep our code organized. We'll talk a little bit about how classes came to be and see how we use them in Python. This is a huge topic that has entire courses devoted to it. We're just going to scratch the surface, but we'll give you enough so that when you see classes, you can understand what that part of the code is trying to do. So to get us started, let's talk about the motivation for why classes exist. So it is often the case that as we are writing a program, we might realize that several different variables are all talking about one single thing. The analogy I like to use here is sort of like the story of the 7 blind mice, if you've ever heard that, where our variables are very limited data types. We can only store numbers or text or other very basic pieces of information. If we were to describe something like an elephant or say a house here, we wouldn't be able to capture everything about that house in just one of these simple types. We can describe individual features with them, like say the room count or the square footage might be numbers, or the paint color and the address might be text. But each of these variables in our program would be entirely disconnected. We've learned about how to store groups of things together already with lists, but lists don't quite work here. Because remember, we said one of the major features of lists is that lists are homogeneous. Each item in that list is the same type of information, and we've got multiple different data points of the same type. In this case, with our house example, we actually kind of have the opposite. There's only one real-world thing that we're describing, and each piece of our data represents a different quality, a different attribute of this one heterogeneous thing. And all of these pieces are different data types, so in some programming languages, we wouldn't even be able to put them in the same list. That said, there may still be a benefit to passing them around together. Say, I were trying to calculate how much a house is likely to sell for. The color, the address, the footage, and the room might all be used in that calculation. So instead of having to pass all those different features around together in 4 or 5, 6 different function parameters, it would be nice if we had a way to put all of these different variables together in one collection the same way we did with our list. So that does exist. And that is what is called an object, which is going to be our container for all of this data. Before we start talking about how objects work, though, I want to talk a little bit about how they came to be. So before we had objects, there was this idea called a struct. So a struct was just a simple description of named fields that each described what they were called and what their type was. So here in our house, for example, we might say that structure of a house is something with a room count, that's a number, a square footage, that's a number, a paint color, that's a string of text. And each one of these, if you recall from our discussion of variables, is going to take up a certain amount of space, some blocks of our memory, our running memory, our RAM. Once we define this struct, one of the big benefits of that is that it allows the computer to compute how much space the entire record together is going to take up. So in this case, we said in this cute little abstraction, 4 blocks for a number, 8 blocks for a string. What that means is if we count all of these, we end up with 24 blocks to represent an entire house. And so once we had defined this struct, later in my program, I would be able to say, I'm making a house called a house in this case here, and immediately the computer would know it needs all of the space for all of those individual fields put together. And this was really convenient because it saves you from having to do separate memory allocations for each one of these different parts, and it creates one variable that can hold them all. Even in these original structs, we started to see some of the syntax that would become common to objects that we use today. For instance, when I had one of these variables here, if I wanted to get to one of these individual fields, I could do that by using the variable name followed by a dot, and then whichever field I wanted. Say I wanted room count. And your programming language would remember how it is that it decided to pack these things. You can see in our example here, if we said this house takes 24 blocks, then the first 4 blocks are the room count, and the next 4 are the square footage. So if I did a house dot square footage, it would remember it has to offset 4 blocks to get to that square footage field of this entire record. And that was the basic way that we used these structs for a long time. But building on that, eventually, people started to realize that it was a very, very common practice to write many functions that each took in that single struct and then either accessed its fields or modified them in some complex, well-structured way. Eventually, programmers decided it would be more convenient if we could group together those functions with the data itself, creating a bundle of both of these things in one single package. So in order to do that, we need to sort of create a template of what that bundle is going to look like. Every time we make one of these things, what are all of the pieces that are related to it? And that bundle is what's called a class. So every class has 2 pieces to it. There are the attributes, which are just like our struct fields. For the class, it is the list of things that one of these objects will need to have. So for a house, the things a house has are those same ones we saw before. Things like a room count, or square footage, or a paint color. All of the data that this class will need to store. And then, attached to that, we have methods, which are the functions that describe the things a house can do. So in our case here, I might have functions that describe how to make a new house, or how to clean the floors of the house, or calculate the cost of the house. And those might not all return something or take things in. A lot of them will just require these attributes that we had before. It's certainly possible to require them. Say, painting a new color might still need an input, which is the new color that you want to paint it. Something like calculating a cost still might return what that final result cost is. But the idea of these class methods is that all of these methods are very, very closely tied to more than one of these attributes. And so it's much more convenient if I'm just able to call it on the object rather than passing in all of the pieces separately, one after the next, in 3, 4, 5 different parameters. So in order to use one of these methods, we do the exact same thing we did for our fields. We take the name of our object, say it was a house, that variable we created before, put a dot, and then put the name of the method, just like we were calling any other function. So if this sounds a little bit familiar to you, like you might have done that already, it's because you have. On a lot of programming languages like Python, there are several types of variables that sneakily create an object for you automatically. For example, in a string, when we want to search in a string, we can call our string variable that we've created dot contains or starts with, we can call these dot functions that are actually class methods, because when you assign a string variable, Python will turn it into a string object. And this is also true of files and a lot of these other basic types where instead of passing the data into a function, after the variable we've created, we put a dot and then put the name of a function. Anytime you see that pattern, we're actually talking about a class method. So the last thing I want to show in this video is looking a little bit about how we would make a class in Python. So in Python, we create a class with the class keyword. We put the word class, and then we give that class a name. So say here I wanted a house class to represent all the things a house can do. I would put class, house, and then a colon. And then indented inside that class block, we would put all of the functions that are part of being a class. And these functions are declared very similarly to the functions you've been using. Dozens of videos we've had where we've looked at them. I would put the word def, put the name of the function, and then in parentheses, put the parameters that are required. The one thing that is slightly different about class methods is in Python, every single class method will take a parameter called self as the first parameter of the function. What that self communicates is it is a way for these functions that we're creating inside this class to access the fields, the data part of the class. Because remember, classes have two parts: the things they can do, which are the functions that we can write, and the things that they have, those attributes of data that we want to be able to reference. And that self is going to be our handle when we're inside the class to talk about those different fields. So for instance, if I were saying the cost of a house were $500 times the square footage, the way I could access that square feet attribute of a house object would be by saying self.square feet. Outside of the class, we'll still use the variable name. If I created a house, I could say a house.square feet. But while we're inside, this self gives us a way to refer to the object no matter which object is calling this function, because we're writing this function once and it's being attached to every different house that we create in the future. So that's slightly weird, but ultimately it's no different than any other function that we've written before. There is just one other quirky little thing about classes to keep in mind, and that is this init function here. So the init function is what is called a constructor function or a constructor method. This constructor describes the steps that need to happen when a class first creates an object. So often all this is going to do is take all of the data attributes as parameters. It's the one place we'll actually need to pass every single element in and assign them to the fields of the object itself. Say, oh, I am going to receive some amount of square feet and do self dot square feet equals that amount I received. And this allows us to set all of the fields at once so that all of the other functions will work and we can store them all in our variable. This is very similar to what our struct did before when it first set up all of that data. But now that we've bundled functions to the class, we can do more here. If we wanted to calculate something on the fly or assign a default value to every single instance, every object created of this class. So that init constructor method is the one other special thing about classes, but otherwise, this is just a description of all of the methods that are attached to this class. And that's all you have to do in Python, because we actually did the attributes right here inside our constructor. So both halves of the class are defined if we just write the methods. But once we have that object, or once we have this class here, we can create objects. And that is one important thing to keep in mind, is just like how when we created a function, no code actually runs when you just declare a function. You have to call that function first to tell it, what am I passing into the parameters? When is this code actually running in the program? In the same way, a class doesn't do anything by itself. A class is just a description. It's like a blueprint of all of the pieces of our house. Here's all of the features a house will have, all of the actions I can perform on it. A house will need a color. It'll need an amount of square footage. But in order to actually use these functions, I need to construct an object from this class. And the way that we do that is by calling this init function. So the one thing that's slightly weird about the init function is because every single class needs to have one, we don't call it by name. Instead, we use the name of the entire class. So for this house class here, I could call my init function by using the word house, the name of the whole class, and then passing in the parameters. And if you'll notice, I don't have to pass in self. Self gets automatically passed in the background. I only need to pass in the other parameters that come after the method. But when I do that, I call that function and it will return to me the entire created record, that object of the class that I can store in a variable like any other return. And once I have that variable, then I can call the methods on that using our dot notation. Say I wanted to calculate the cost for my house. I could say a house dot calc cost. And that will go to that version of the house, use all of its values for self. It's sort of like this thing to the left of the dot ends up getting passed as the first parameter, this self here. And then that's where it looks to find the square feet and the color for its cost calculation there. But otherwise, that method will work exactly like any other function we've seen before. If we return a value, we can pull it out. If we pass something in, it will be available in the parameters up here. But it gives us a nice and convenient way to group together a bunch of different functions that are all related to the same variables and organize them into one single thing that we can assign to a single variable and call functions on off the back instead of passing this thing repeatedly in to a bunch of different functions. So that's the motivation of classes and objects. Like I said, this is a topic that has a lot of information on it. There are entire semesters worth of college classes just devoted to talking about when we use objects, how we write them to be flexible and reusable. Those are all very important discussions. But here today, hopefully you've just seen just enough of how classes are used to understand what these things are in a program. These classes are a way for us to bundle together related functions and variables into one single blueprint, a template of a way to organize our program. In order to actually use them, remember that we do need to call a constructor function. We need to actually say, here's the recipe for a house, but here is a house that has this many feet and this color. It might be blue and it has 7 rooms and whatever actual data we are storing and using in our program. And once we've constructed one of these objects from the class, that's when we're able to use our dot notation to access the fields or to call functions that are attached to that object's class. So that is our introduction to objects and classes. And that is actually the last topic that we have in Python. So hopefully you enjoyed these videos and they were useful to giving you just a bit of exposure to the concepts of programming. There is still a lot of information out there, so definitely keep growing, building, practicing your programming. But hopefully this was an enjoyable series of videos to go along with your educational journey. Good luck to all of you, and hopefully I see you in one of my classes in the future.